Yes, hello everyone, and very good morning, and assalamualaikum. Thank you for being here. So today is the 49th Distinguished Lecture Series organized by the Faculty of Engineering, University Technology Malaysia. So first of all, I would like to apologize for those who know me. This is not my actual voice. I'm recovering from cold and flu. But I'm okay now. I'm moderating the session today. So basically today we have Prof. Ellen Do from University of Colorado University in USA. So Prof. Ellen and I, we started off back in 2015 where I first met her personally because we worked together on our initiative on bringing Asian HCI work to Kai community. So that was my first time having spoken with the person herself in Seoul, Korea. From then onwards, we kept in touch and we worked together, especially on Asian Kai Symposium. And fortunately enough, today we have Prof. Ellen herself to be giving her talk on a very special talk, which has the word magic in there. So I'm sure this would definitely make us wanting to know more what Prof. Ellen would say later on. So I really hope that from today's talk, from her talk, basically, all of us, the audience, and mainly us from the engineering faculty or with any computing background, we can appreciate the fact that doing computing and engineering is not just about, doing dry stuff. We can actually do so many fascinating things with technology. So with that, I will pass to Prof. Rafiq, our Dean of Engineering Faculty, to introduce Prof. Ellen. Okay, go to you, Prof.
Thank you, Prof. Masita, for chairing the session. Assalamualaikum warahmatullahi wabarakatuh. Welcome everyone to our 49th UTM Engineering Distinguished Lecture Series. My name is Muhammad Rafiq and I am the Dean of Engineering, University Technology Malaysia. Today, it is my utmost pleasure to welcome Professor Yi-Luen Do from University of Colorado at Boulder, United States of America. A bit about our distinguished speaker today. Yi-Luen Do, who is a full professor at the Atlas Institute and Computer Science, invents at the intersections of people, design, and technology. She works on computational tools for design, especially sketching, creativity, and design cognition, including creativity support tools and design studies, tangible and embedded interaction, and most recently, computing for health and wellness. She holds a PhD in Design Computing from Georgia Tech, Georgia Institute of Technology, a Master of Design Studies from the Harvard Graduate School of Design, and a bachelor's degree from National Cheng Kung University in Taiwan. She has served on the faculties of University of Washington, Carnegie Mellon University, and Georgia Tech. From 2013 to 2016, she co-directed the Keio-NUS CUTE Center in Singapore, a research unit investigating connected ubiquitous technology for embodiments. She enjoys playing the Djembe and performs at festivals with other venues with the Sensua Players. So that is a brief biography of our distinguished speaker. Here now is Professor Yi-Luen Do from University of Colorado at Boulder, USA, on making magic with creative technology and design. Professor Yi-Luen Do, over to you.
Okay, let me share my screen, okay? Good morning, everybody. Okay, I'm going to share my screen. So today my topic is making magic with creative technology and design. So I think the first question many of you would ask, why should we engage in creative technology and design? And I think we are living in the world that we're thinking about what the future will be. And this is the opportunity where we can make technology creative, and we should be designing creative technology. And this is also talking about cross-disciplinary creativity. So imagine engineering embedded with computer science, embedded with people, embedded with technology, all together. Okay, so if you ask me to define what is creative technology and design, there's so many explanations. There could be system, computation, artificial intelligence, computer-supported collaborative work, spatial reasoning, all of the above, design computing. Okay, and another thing is that I want to let you know, at the University of Colorado Boulder, in the Atlas Institute, we have degree program that we call Creative Technology and Design for undergraduate, master, and PhD. So we are cross-disciplinary, not just computer science, not just engineering, not just media, not just art, not just design. Okay. So a lot of things that you will see from my talk is that we build things, we implement, we program things. The thing is both physical and computational artifact. So think about software on your cell phone, think about your furniture, interactive. So we are building the object to think about what the future will be, to think about how we want to live our life. And this is also a way of working. So we don't just think, write software. We think about, let's build a prototype, let's build a system, let's deploy with people, and let's see how it works, right? So human-computer interaction is also seeing how human interact with the computing and to see what things work, what things doesn't work. And it's also beyond the computing. We are living in the world with computer, with phone, with furniture, with clothing. So what we're doing is thinking about and building the methods and tools to help us make things. We are making things every day. We're making our speech, we're making our meal, we're making our artifact. Okay. So I think one of the topics now you're very curious in my title is about creating magic. So I want to explain to you that I think when we engage in creative technology and design, we are creating magic. Okay. So this is not an invention by me. This is actually come from a science fiction author, Arthur Clarke. So some of you may know there is a movie called 2001, Space Odyssey. Okay. Arthur Clarke helped wrote the script for that movie, but he himself was also an inventor, engineer, and inventor of the communication satellite. And one of the things he said that I really love is that he said, any sufficiently advanced technology is indistinguishable from magic. Okay, so think about the first time when the car was invented. It's very different because traditionally you have a cart with horses or different animal pulling it. And when you have a car walk by itself, it seems like magic. Okay, you have engine, you have wheels, you have control. Okay, or we think about the first time, like people, the first time they turn on the switch, right? Electricity come, lighting come up. So that's like magic. Or when the telephone was invented, right? Normally you can talk to the people in front of you, but you never thought about you can talk to a remote, another person with wire. Now we even have things that's wireless. Okay, so I think in the process of doing technology design, we should think about how to make it advanced and how it appeared to be magical. So that's the first idea. Okay, so this is what you see in the Atlas. There's a website, atlas.colorado.edu, and you will see people coming in. There's a different laboratory, and we have courses, we have laboratory, we have build stuff. And if you come, this is our building. This is called the Rosa Atlas building. And so 3-story highs, we have different classroom, laboratory, we have a black box theater, we have different lab, and you can see there's a lantern, the beacon there. So the student actually write programs so they can control and change the lighting pattern. And this is the Interdisciplinary Institute. And we like to say we work on radical creativity and invention because we want to think critically and we work on research and experiment about how idea can turn to reality. So if you come, you will see interesting stuff that you don't normally expect. So you will see artists writing software, or the robot in front of you is trying to read your body language, trying to figure out what it's trying to do. Are you trying to go somewhere? So maybe the robot will lead you to places. And many of us, it's not just one discipline. We wear many hats. You can be an artist and designer and engineer and technology and humanitarian all together. So this is a lively community. We all build things together. And we also very curious. We think about something and then we say, let's try it out. Okay. So if there would be a test after the talk, I have two major ideas I want you to remember. So one of the things is that, so many of you will know about Alan Kay, right? He was credited for the idea of one computer per child. Also, he worked for Apple Computer sometime. And he also invented several other programming language. And so people will ask him like, hey, Professor Kay, like, what do you think the future will be? Like, do people live like us? Do they change the way? Do the environment also change? And then he said, don't ask me. The best way to predict the future is to invent it. And so the idea is that instead of letting other people inventing the future, we have the ability and we have the curiosity. So you should be building the technology, engineering the technology, design it for the way, for the future that we like to be in. And then, so one is about invention, the other one is about magic. And I already talked to you about magic. We want to make things, technology that is magical. Okay, so I'm going to give you a tour of the Atlas laboratory and studio. So I'm going to go through like 8 of them. So one of the laboratories called Emergent Nanomaterial. So they work on things that you may not be able to see in your normal eyesight. Then we want to talk about Unstable Design Lab because they think about design is never finished. It's always unstable, it's moving forward. And the Living Matter Lab is about the future of healthcare. And superhuman computing is talking about augmenting human abilities. And the Iron Lab, you can guess, is about human-robot interaction. And the Typo Studio is playing with language. And the Thing Lab is about transformative interaction for the next generation. And finally, my lab is called Acme Lab. And so some of you may know that Acme is like a company that makes everything in the Looney Tune cartoon, okay? And so my lab is like a community that makes everything. And also Acme stands for Creative Machine Environment. So I'm going to give you a tour one by one. So if you come to visit the lab, I will show you around. Okay, so the first one, Emergent Nanomaterial. So you can see here, there's a lady with a tattoo, okay? And you can see the tattoo is actually conductive. And you can have simple LED light that could light up and a tiny little button cell. The idea is inventing the future of material that could be nano that you cannot see. So the next thing you see here is that here's a person's hand and you shine a light on that and the tattoo, the two blue-green dots shows up. And then gradually it will fade away when light's not there. And so the idea is that instead of tattoo, you put color. The color could be invisible. The color could be a sensor, like this is responding to ultraviolet. So maybe you're outside too long, so your tattoo starts showing up, say, you're about to get sunburn, go back into the house. Or imagine you could have like insulin level very low, so you're about to having problem, and it will show up to tell you, hey, time to take a shot or eat some food so you don't pass out. Okay, I'm going to introduce you to the lab director, Carson. Let him talk to you.
I have a background in chemistry, and I'm also really passionate about art. And there's a real connection between chemistry and art. I think chemistry is this really creative discipline. There's this famous quote that says, chemistry creates its own object. It's one of these sciences where you're not studying something that's already out there, you're actually making something. My name is Carson Bruns, and I direct the Laboratory for Emergent Nanomaterials. One of the projects that we're working on in my lab is what I call the Tech Tattoos project. In that project, we are using kind of nano-engineered particles as tattoo pigments that will change the function of your skin rather than the color of your skin. So for example, we have tattoo inks that will change color in sunlight. We have tattoo inks that will change color when they're exposed to heat. And we're working on tattoo inks that conduct electricity, like a tattooable wire. And we're interested in tattoo inks that can also sense other things, perhaps biological signals in the interstitial fluid of the skin. And yeah, I think the sky is the limit for this project. Tattoos can give you superpowers.
So he said tattoo can give you superpower. So think about things that you could be embedding or engineering on your skin. The tattoo is more than just color. It can give you superpower to know when to go out and when to eat food or all kind of things. Okay, so that's the first lab. Let me walk you to the second lab. So this lab is called Unstable Design Lab, and they're interested in fabric and textile design. Okay, so normally using textile is just textile, but this textile have the threads that was thermochromic ink. So you can see the pattern, the top one, the blue one. So one is invisible, one you can start seeing the white number. So when you change the temperature, the thread, the ink exchange color. So the bottom one you see, all of them is actually exactly the same thing. But when you heat it up, it's changing the color from red or to white. Okay. So normally when you do a smart textile, you have to weave them. So you have to sew, use this machine, you put these things together. And this one is that they have the conductive thread and also have the thermochromic thread. So they're different color. And when you put the current on, you can start seeing some of the blue or black or red, they're disappearing. So you can see like some of them disappearing now. Okay, when you change different colors, so you can change the mixture of colors. So they could be purple, they could be yellow, red, white. Okay, so that's an interesting thing because then you start thinking about this is not static anymore. You could be changing the fabric. Or this is another example. This is like human and wind collaboration. So imagine you weaving your textile, but then you come outside with natural, and with this tiny umbrella, when the wind blows, then different things start moving. So instead of you designing your pattern, you're working with the wind to design a different pattern because they will shift different one and you put different color in. So this is another way of thinking about, oh, what if I can do engineering and collaborate with the wind power as well? Okay, so I'm putting Laura Devendorf, who is the laboratory director of the Unstable Design Lab, to talk to you.
What if our clothes could remember the things that happened when we were wearing them? What if it remembered the physical impacts on our bodies from certain engagements? My name is Laura Devendorf, and I am the director of the Unstable Design Lab. The work in textiles and smart textiles has offered a lot of different things in terms of new kinds of technologies, but also in thinking about who does innovation and who we think those kinds of people are, and different ways of just engaging with technology. It's in a thread or a fiber, it's very different than when it's on a computer behind a screen. One of the things that's been exciting is bringing the weaving community together with the engineering community on campus, which is becoming increasingly interested in smart textiles for applications like medical diagnosis or space flight. By creating a space for this work, we can show how craftspeople have really developed embodied relationships with these materials and structures in ways that are incredibly sophisticated.
Yes, so you see she's putting the hair dryer on top, so it's changing the temperature, and you see the blue and red actually disappear, right? And so think about all the possibilities. So this is Laura holding her daughter with the fabric that she weaved. And so as her daughter was growing up, different part of the body of the clothes is getting touched, right? And so you are actually recording like the history of her growing journey. Okay, on the right-hand side, here's a wrap, but also with the thread. This is right where you tied it behind, under your waist. And so you could be breathing, and so you could be monitoring your biosignal and knowing that, oh, maybe you're breathing faster right now, maybe you're having an asthma attack. And so you could be sending information to another place to call your doctor or doing all kind of things. So think about the fabric, think about a smart textile that could be protected of you, or that could be a detection about when you got hit as a sport or even an astronaut's uniform. Okay, so how do you design that? So Laura and her students are working on the CAD software. So you can design your pattern, putting different threads, putting different material. So you can invent the different patterns, for buttons, for slider, for different interaction as well. So they call this AdaCAD, so a crafting software for smart textile design. So you can see there are applications, but there are also tools to help you to do the design. All right, moving on. Next project. So we just talk about clothes. We talk about skin, tattoo. We talk about clothes. That's all outside of your body. What if something that you want to know about your own health, your own body? So Living Matter Lab, the idea is about the personal health care of the future. So traditionally, you go to the hospital and they take your sample of the blood or your urine or your sweat to analysis. They send it to the laboratory, they come back in a week or 2 weeks or months, and then you're waiting, trying to figure out like what's wrong with you or what's going on. So in this lab, they're working on this bio chip right here that you can take your sample of the fluid and program and to do analysis right there. So you can have the result right away. And I will let Marilla talk to you in person, personal biochip.
At Living Matter Lab, we look into how to take certain processes of healthcare and bring them closer to the patient. For example, looking into diagnosis, instead of you going to the doctor's office, have your samples taken and sent to the lab, we build devices that will help you do these things at home. I am Mirella Alistair, leading the Living Matter Lab at Atlas Institute, University of Colorado Boulder. The specific technology that we're working with for now is in the realm of digital microfluidics. We call these devices biochips, and they are machines, small machines that move droplets of fluids. These fluids can be blood, urine, physiological samples. These devices help us automate the movement of fluids in a way that they replicate the exact procedure that happens in the laboratory, so that instead of having a lab assistant or a robot pipetting your blood samples, we can have a biochip moving a droplet of your blood and reacting with various regions to get the result that you need.
Right. So they are thinking about personal health care. So instead of you going to hospital, you could be taking control and being able to do analysis right there. So in her lab, they're working on many different biomaterials. So this is one of the projects that the student work on called Mycodomicilia. So what they have is they grow the mushroom and put the mold so you can make sustainable, reusable object. So that could be your cell phone cover, that could be jewelry, that could be a bowl or container. So those are mushrooms. And so when you don't want them, you can just put them, let them degrade, and that could be part of your fertilizer for your garden. Okay. So that's very interesting. You think about your personal health, but also bio challenges with the environment and sustainability. Okay. So next, superhuman computing lab. So this lab is talking about humans all have different abilities, right? So somebody could be visually impaired or hearing impaired, or maybe have different abilities. So what would it be if we can use computation to help it make everything accessible or even augmenting it? Okay, and that could be a wearable, could be a mobile technology. So first example, this project is called Wear It Loud. Thinking about hearing impaired, so we have the implants that people wear for the hearing implant. But then you realize that a lot of people actually customize them, decorate them as part of the jewelry or decoration. So we understand when we design, it's more than just function. You need to give them ability to customize and to suit their personal needs. So this is about how the different devices could actually evolve, and that's interesting. Okay, and the second one is about visual impaired. So some of you looking at the screen, you can see me, I'm doing gesture. So on the screen here, this is actually like an educational movie. They're talking about physics and talking about motion and when you drop the ball, right? So the person will be doing animation and you can see the movement of the ball. But if you are visually impaired, you will not see that video. And even though the description is telling you this one's moving, that one's not moving, you can still not feel it. So the idea here is like giving a tool so people can put little robot, you can draw which way they're moving, which way they're going, and then the robot would follow that. So this is the video annotation tool for robot. And let me show you the video.
In the Haptic video player, the robots are controlled using visual paths and optical codes displayed on the touchscreen. The user can touch or hold the robot as it moves to get non-visual access to the motion of important objects as they move in the video.
Right. So the nice thing is that if you have a movie animation and you have a tablet and you can draw which way the robot will be moving, and for the visually impaired person, they can touch it, they can see it, they can hear it. So other people can see the video and they can feel the video. Okay, here's another one about visually impaired.
We have developed Braille Blocks. Braille Blocks is a tangible block and peg set with associated educational games on an interactive web application. One of these games is the animal name game. Parents play an animal sound. The child guesses the animal's name by building it with the blocks and pegs. The parent clicks the Check Word button to check if their child has built the correct word. The system outputs what word is spelled. Braille Blocks uses tangible learning to create an engaging, collaborative learning experience.
Right, so you can see the Braille is used as a game, so children can learn and spelling and it could be checked. Okay, so now we start talking about people communicating with another person. So for the Braille, you can communicate with another person. What if you're communicating with a robot? So the Iron Lab for interactive robot and novel technology, they're talking about human-robot interaction. So one example is that, hey, if you are flying the drone, quite often you look up, look down, and then you don't know which way the drone is doing. So one of the projects they did here is putting a avatar or surrogate of where the drone should be going. So you know exactly where they're going to be and you can see when they achieve the goal. So having the interaction for you to see the robot is really important. I'm going to put Dan Safer on the screen to talk to you.
So robots are really exciting because I think they have a huge potential to help us in all sorts of different areas, from space exploration to manufacturing to home assistants doing our laundry or doing our dishes to search and rescue. I'm Dan Safer. I'm an assistant professor in the Department of Computer Science and the Atlas Institute here at the University of Colorado Boulder. I direct the Interactive Robotics and Novel Technologies Lab, which we loosely abbreviate to IRON Lab. We focus on improving the capability of robotic systems in working with people, and we do so in two major ways. On one hand, we look at how can we improve communication and exchange of information from people to robots. So we look at developing new computational models that capture user intent so that the robot can better assist them. And then we also look at communication the other way, going from robots to people. So how can we design robots that work more effectively with people, that people find more intuitive and natural to use?
Right. So the idea is that human-robot interaction. So in this case, like, let's imagine the robot knows what you're talking about. You say, hey, grab me that cup. And it could ask you, that cup, do you mean the one that's closer to the table or farther away? So being able to communicate, and the drone example is for you to communicate with the robot and for robot to hit the goal, so you also know, so a mutual communication. And I'm going to jump to the next one. This one is called Typo Studio. So the idea is about perception of language. And if you look at this, you see in the English language, as some of the words are very interesting, like they are part of the other one, right? Here, there, yes, no, right, man, woman. So this is a many installation that is happening in the hotel or building facade, because by changing the display, people may have a different perception or even ask questions like, what does it mean? What is the language telling us? And I will put Joe to talk to you.
My work is an exploration of language and technology. So I like to look at the way that all kinds of technology shapes how we use language, how language communicates things, and how eventually language actually shapes us as humans. I'm Joel Swanson. I'm an assistant professor in the Atlas Institute, and I'm an artist exploring the relationship of language and technology. So right now I'm teaching a class on computational writing. So we're looking at natural language processing and a lot of other aspects of computational linguistics, but using them as tools for creative expression. So how can we use things like Markov chains to create unique poetic texts? And again, it's kind of looking at technology, but ways of repurposing it for interesting creative uses. But the other thing that I think is really exciting too is we're all learning really robust, interesting technologies. So I really like to integrate this notion of technology, right? Is it digital? Sometimes it's historical and analog. but it all kind of motivates my work.
Yes, and so you have to make sure that the technology work, you're designing it, you're engineering it. Okay, like 2 more labs. All right, so next lab, this is called Thing Lab. It's transformative human interface for the next generation, because the idea is that when you're working with everyday interaction, talk to people, talk to your furniture, talk to other things, what would that mean? Working with your hands. So I'm putting Daniel lighting there to talk to you.
If I make something with my hands, it's going to look different than if I were to design it on a computer using a mouse. Those are going to be different objects. I'm interested in what are those differences and how can we build the best possible interface to really help us create. I'm Daniel Leitinger. I'm a professor here at Atlas and computer science, and I direct the Transformable Human Interfaces for the Next Generation Laboratory, short Thing Lab. And what we do at the Thing Lab is we want to make digital information tangible, building computer interfaces that will allow you to touch and interact with digital data directly using your hand.
Right. So it's important what he said is about using your hand and for people to be able to feel it. So here's one example. This one is called Dyna Block. And so it is a 3D printing that is reusable. So you have this tiny block, and when you push it up, this is engineering. So it's not the plastic material. This is reusable. You can print a table, you can print a chair. And what happened here is that each one is a block with magnet. So you provide this mechanism to connect and disconnect. So you can build airplane, you can spell out words, and when you don't want it, you push it back. And so the material is there reused. So you can use it again and again. Okay, so here's another one. This one is called lift tile. So imagine, so that's a tiny little thing. What if your environment, like your tile, is also transformable? Okay, so you can see like a tile is going up, and of course you need to have a way to communicate, but it could be enough for you to be setting or working on it. Right, and so with this hydraulic power as well, or pumping, you'll be able to shrink and move around. And so what if you're in a virtual environment, right? So you could be interacting and they could going up and down. Or this one is like your environment. And maybe the environment is telling you which way to go, okay? And so the idea is about how you can interact your environment. That could be multiple ways. Okay, finally, this is my lab. So as I said, Acme Lab. So this is a loop. Acme, A stands for Acme, C for creativity, creative, M for machine, and E for environment. Because humans are creative machine. We keep on coming out interesting ideas. But we also want our environment to be creative. We want machine to be creative. So can we think about what the future of interaction might be? So I'm going to show you a couple different projects. So this project is called Makeup Magnets. As you can see here, it's 3D printed, but designing with embedded magnet. Okay, so you know magnet, they attract and repel. So you can design all different kind of gadgets and put in the magnet in different places. So you can create a switch, you can create a push button. And it's pretty satisfying to be able to move it and feel it. So you can see all the magnet and then put a little ball bearing. And so this is like a dial. Yeah. So instead of having complicated, expensive gloves, what if all the interface are gadget that you can 3D print it, you can design it, and put a magnet. So this is a simple joystick. So they're only like 2 magnets, and because as you push, and they either attract or they always come back. Right. So the idea is that any gadget you can think about, push, you pretty much can design it. And so instead of you buying things in the shop and fit your project in, why don't you design your own? This is slider. right? So you actually have magnet in all of that. So as you switch, you know exactly where things are. Okay. So there are many different magnet gadgets that you can build, and I think you can build things that you can rotate, move around, and that's all fascinating. Okay, so this is pushing, kind of combining, yeah, joystick and all that. So one of the questions people ask, like, oh, so what did you discover? So we're trying to do is systemic to see maybe there's a linear, there's a polar, the angular, and you arrange the magnet whether in attracting or repelling, depends on the location. So you're engineering what things are, look at what the magnetic field and how they interact. And so as a result, you can come up with a map like, oh, if you do that, this is the interaction. If you do that, this is the interaction. So we can map the whole things out. And many of the things could look exactly the same, but the interaction could be different. So that could be a push button, or that could be a dial, that could be a movable thumbtack, okay? And so people ask, why are you doing that? What else can you do? Yeah, of course, you can 3D print your own toys, right? So this is a tiny little frog. There's no glue or screw in that. It's just 3D printed, so you can take it apart because they will snap together, and there were magnets inside. And so as he take it apart, you can see, hey, those are repelling magnets, and that's why when you push it, you always go back because they're not supposed to snap together. So yeah, so you can design your own toy. Okay, and of course we can also design tangible input. Like what if we're designing your own game controller? Okay, so in this way you can see you can print this whole thing out. Yeah, with push button and rotation at the same time. Okay, if we put the whole effect sensor in there and we connect that to the computer, so we can connect that to a game that we build. This is a controller. So you can see which button is pushed. Okay, and you can also see how it's rotated. All right, okay, so now you can see like this could be a simulation exactly as what you're doing. And so you can use this as a game controller to control a game. And you will see next, for example, what can we do with this game? For example, this could be a palm game. So as you rotate, you're changing the wall. And when you're hitting the ball, you're shooting, and so you're competing like who get more balls. Okay, so that's one example of doing games. And another student saw this project and said, that's interesting, so let's build another game. So this game is called Hot Swap, and they actually went to GDC, the largest like 4,000 or 5,000 people game development conference, and won an alternative control game award because they actually 3D printed and they built the whole things in Unity. So this is a game called Hot Swap. So as you can see here, this is the 3D printed gadget, and this is a pilot game. So you have this ship going on the sea. So one ship, 5 input, and there are only 4 slots. Okay, 2 players. So you have to communicate and collaborate with people. So you need to put the slot there to control the operation. So for example, like if you put this racking, you can change the speed of the ship, right? Or you put the helm, you can change your orientation direction, which the way the ship is moving. And this is cannon, loading the cannon, 1, 2, 3 on the right hand side, move to the left hand side, shoot, yeah, fire. And then you got hit by other pilots, so you have to put out fire. Okay. So you can play, and you have to collaborate, and so yeah, on the right hand side, on the left hand side. It's a lot of fun. So we took it to the game. There are 2 different game conferences, and we won 2 different awards, and thousands of people play with it. They found it interesting. grown-up or children because it's tangible and it's something you can play with. So I think one of the ideas here is the everyday object could be interfaces. So you can 3D print your things, but there could be other things. So some of you may have noticed what's behind me. So that's the logo A. So we design our Atlas logo. We have many different labs. Each lab actually take a different A. So you can write a software to change and see how things are. And I've been using that for the slides. Okay. If you go to Atlas website, if you click on the logo, you'll find like a little paper toy, origami pop-up toy that you can fold and make toys. Okay. So another thing is about everyday object. Could be an interface. This is a lamp that is listening. Right. So the lamp could be a sensor, and so you can program it to listen to different pattern or different pitch, and then have different interaction with different patterns or different colors. Or here's another one. This is a jump station. So you can see there's an LED light in the middle. So different musical instrument is actually lighting up the different part, and there's a PVC pipe. We painted it, we have bucket, and we have hands or a xylophone, and we use that as a musical instrument. And so the control, the engineering part will also notice that if you're in harmony or you're doing different patterns or different part can light up, say, hey, you're winning. Okay, here's another one. This one is about paper interface. So we find out that there is this scientific laboratory paper with carbon coated. So if we etch it, then we can actually create like sensing the capacity. So you can use that as an interface. So you can see like as you bend or fold, you detect when the action is happening. So you can fold it into like origami, could be like a lantern, and the computer can sense and do the simulation of what exactly you're doing, right? So that could be a circular foam or angular foam bending or crashing. All right, so then you said, so what is this? Like everyday object could be interface. What if we build a lamp with paper? And we can pull one side to dim the light, or we can pull the other side to make it brighter, right? So in a way, you can program your environment as long as you be able to sense it. So paper could be an interface. And then make it dimmer, make it lighter. So imagine your clothing when you're moving, maybe you're changing it, and so you can change the music, you change the lighting. So here's another one with paper. So the idea here is that we're talking about markers. So quite often we think about augmented reality. So here CV means computer vision. This is what computer can see. So the same marker, if we separate that into like a pop-up, we can create a marker that could be disappear or appear, depends on the interaction. So here's one example, like what if you have a table and an infrared camera underneath so you can see your marker, and then you have your paper interface. Right, so computer can see that it complete the pattern, so I can use that pattern to do another simulation or generate different things. So here's the application. So for example, like we learn about
Company A sold 20 apples. Company C sold 30 apples. Company B sold 1.3 times the amount of apples as Company C.
So quickly.
Company X started the fiscal year at 22 points. Company X decreased by 36% in the second.
Right, so you can have information quickly display or interacting just with paper. So here's another example. Let's say we have a pop-up book and we have the marker on that. A computer is seeing it. right? So this is, for example, like the play theory about how the different continents were move together and changing, and so creating mountains and stuff like that. And you can have simulation on a computer at the same time. And this is for paper for different prototype. You can slide it through, change the volume, change the beat. Okay. And computer vision is showing you which part is being recognized. So you can change the speed or change the rhythm. So you could have an instrument. All right. So you can quickly build prototype without having complicated things. So this one is a game. So paper as a game. So you have to be careful because you pull too hard, then you will lose. And so maybe get you to be careful in playing game, competing. But then it's also nothing to worry about. You can replace and do it again. Okay. So paper interface. And I think, okay, 2 more projects, then I'll be done. So this one is still on the idea about environment. So this is a table, that's a Roomba, and those are coding shifts. So think about you are in virtual environment, and your environment actually is controlled by the robot. So it depends on where you're moving, you could be interacting with that, right? So you don't really have a full wall. You can have the table and chair, and they move around and come to you. And so you can interact with them. Okay, one more. So those are just robots moving the furniture. What if you have tiny robot that is on your desktop and a whole bunch of them? Okay, so this robot, so you can see it's 3D printed, and the extension is actually the tracing paper. So you can like shrink them or move them, and then you can program the robot, right? You move one, want them to have equal spacing, and each one is that this is the linear actuator, so we can move them up and down, going to a Z direction, or you could be extending on both horizontal, like X and Y. Right, so there are many ways you can transform the robot, like they move around, or they go up and down, or they even expand like origami or Hopper sphere to 3D. So there could be multiple ways of transformation, and you can also think about how this could be application for you. Tiny little robot. So this is the US map. So let's say each robot go to a state. It tells you how many populations in there. And then you move robot to another place, you know, oh, this is a different state. We actually have a lot less people doing this. And this one is like, okay, you don't want to clean your table, your little robot will help you clean your table. So the idea is that you work with the robot, and robot knows what you're doing. And this one's cute. So you just put hot water. It's too hot. So your robots come to protect you. They raise it up to tell you it's too hot, don't touch it. It's going to burn your tongue. Okay? Then a minute later, it's cooler. So now it's ready to drink. So it moves away. So coming out with like robot have sensing, understand the environment, and interact with you. Okay, so this one, I think a lot of people find it interesting. So if you're designing things on computer, 3D, so what if you change your CAD model and then your robot is changing? So you can see, oh, this is how big that would be. What if you say, how about I move this? So it could go back, the robot and the computer communicated. And this one is just simple robot as a tool. So you can use it to draw or do things. And then you can communicate with the robot, go away, or come together. All right, so, hey, there are 4 of them. What if you should remain as a rectangle? So when I move it, everybody move. Or give me a triangle. So the robot show me 3 of them is a triangle. Yeah, and 4 of them is a little rectangular shape. And then maybe you also have, okay, have 6. So they will communicate and figure out do the hexagon, equally spacing. Okay, so on that, I think I will end my talk and will stop sharing. I cannot hear you.
Yeah, so sorry, I didn't realize that I mute the mic. Anyhow, so very much thank you of your talk. It's very, very, very interesting. There's so much that we can learn with creativity. It can spark so many inventions with technology and engineering today. So I think we can now get some questions from the audience. Before that, maybe I can start with my questions first. You know, with lots of projects that you've been doing, how long it usually takes you to complete from the scratch until you get it done? Is it like a year or months, or how normally it happens?
Depends. I mean, some project could be a semester. People come out with a prototype, so that's really fast. And then once you test on people, maybe you continue to improve it. And so maybe you don't write a paper until you test it with people and make it better. So that could be a year, or some of them could be go on for a longer time because you want to make it better and better. So many of the projects I show is probably a semester or a year, so it's not very long term.
That's interesting because it can be done in very quick time. You know, in one semester you can get lots of things happening. But may also know in terms of how do you normally initiate the creative process with the students?
I think there are multiple ways of doing the creative process. So sometimes brainstorming, sometimes it's like being curious and talking about what if. Yeah.
Okay, that's nice. Because you know, sometimes when we talk about creative process, not many people have confidence, you know, thinking that if is my idea okay, can it be done? Is it feasible? Is it doable? But I think with your lab and at Colorado, mostly it's like nothing is crazy, right? If you have ideas, just go for it.
Yes, and I think a lot of time is that talk is cheap, and if you build something, then we can play with it. And that's why in the beginning I say we build object, and the object is something to think with. So it's not a final product. So you build something, you test it, and then say, oh, that works. Or something that you wish you have, and then you say, oh, that's going to be complicated. Let's build the first prototype, see how they work, and then let's improve over the time, over the years, over the months, right? So you see whatever the makeup magnet. So originally they say, oh, here's a 3D printer. What can we print? We just print everything static. So can we make it more interesting? And so they start putting magnet inside. And once they put the magnet inside, I said, can you sense the interaction? So the thing just go on from one thing and to the next.
Yeah. Okay. That's nice. Let me just check whether there's any new questions coming in. Hang on. Okay, not at the moment. Okay. In terms of you know, at the beginning of your lecture, you mentioned that at the Colorado University, the program that you offer is creative and technology design, even for the undergraduate students. So, what are the elements that you bring in? Because you said it's not just art, it's not just engineering, it's not just computing. How do you balance things out?
So we have, for example, for undergraduate program, we have the core curriculum. So core curriculum could be code, object, form, sound. And so each one of them, they're learning the different part, right? How does the sound work? How do you engineering the sound when you're writing the programming? Or object, what kind of object can you build, both in 3D printing, fabrication, but also how to make object interactive. So they're doing microprocessor, sensor, actuator. And so I think our education is not just a traditional disciplinary education, we actually cross-disciplinary. And so all the undergraduate students, they have to do a capstone project.
Oh, okay.
And so finally, like before they graduate, they will have one semester looking for client or looking for a research question. And so sometimes could be an industry saying, we have this issue we'd like to resolve. And that could be a mobile phone application, that could be a website. to be interactive furniture. And so they come say, hey, we want to explore, and then the student either do it solo or sometimes they will do collaboration group project, like a couple of us do something. So like some of my former students, they actually started a company because they were building electronic breadboard, and they thought that traditional breadboard is hard, so they want to design something for children that they can do. So they put magnet, they put like clear board, they put story board underneath, and so the kids can like snap, and so that's make the connection. And so they just went through a Kickstarter campaign. So I think for undergraduate and master program, a lot of time is exploration. And our project like code have computation. So it's like programming 101 and programming 102, but then the sound is like sound engineering and music interactions, right? And so, for example, I showed the Joe Swanson talking about text, right?
Yes.
They're writing software to understand text and display that. And so sometimes you could be having a mobile phone and having a mural. And so behind me is actually a Snapchat filter by one of the students. So they just say, okay, what if I can put something behind me? And so anywhere I'm in, so it's moving around.
Yes, it's very interesting. Okay. Yeah, all right. Oh, okay, there's one question coming in. Would you like me to read it? I think, yeah, it says here.
Yes.
Yeah.
Right. So question is about so many cool stuff. A lot of them is about design thinking or computational thinking or critical thinking. So I think when you should say start, they should start like when they're in college. I think in a way they are curious, and our curriculum want to make sure that you do things, don't just read and just write or take exam. You're actually building stuff. And I think that's a component. And they have to think critically. It's like, if you build this, so we say, that's cool. And who's going to use it? So we still ask that question. They say, oh, my friend is going to use it. How am I going to do that? So many of the things could be like science fiction. So you think of little robot. So, hey, in the future, we will need that. Or if we go into space, right? Space habitat, you're not going to be able to bring everything. Maybe you will make a 3D printer on Mars, and they will reconstruct and build them. And so that could be your building, your furniture, your environment.
Yeah, I think the question. Oh, there's another one. For shape changing swarm robots, which principle are used? Sensing the temperature.
Okay, so I can share with you my slides, so you can go read the paper. And so some of them, so some of the example is that you could be sensing anything. So it depends on what sensor you want to put in. Could be temperature, could be air pollution, could be size, could be weight, right? So let's say if your furniture knows, your chair knows that you'll be sitting all day, maybe you should move or tell you to get up, you need to exercise. So what I show is the example. It doesn't have to be there. And so you can come up with different scenarios. So what if all the object, your table, when you don't want it, they can reconfigure themselves. Or today you have hundreds of people coming for a party, and then they sense people are getting around, so they start moving. Okay, so that could be science fiction, but that also is doable. So think about engineering.
Yeah, it's interesting. Oh, okay. See, everyone is saying the same thing now, because all this while they don't imagine that we can do these sort of things. So so that's another question there. How's your invention end up? Does it go to a commercial market on sale?
Okay, so the project I showed today is not on the market on sale, but then there are projects in the past that is on the market. So for example, there is a company called Modular Robotic. So they have this little robot that you can program, and then they could behave. So it's been a company that people can buy it. And then we have a company doing sketching, and we have a company doing different things like the education board. So I think some of the things that for overview, everybody in the university. So one of the things is we learn knowledge, but we can also create new knowledge. And yes, we can go and spin off, become a startup company. So yes, we do have a couple spin off. I didn't show them because I thought it's cool to see what people do at school. And then some of them actually go on become a company. Yes.
Yeah. Okay. Yeah. I think, we only have that for today. Running out of time now. So I pass the session back to Prof. Rafiq.
Mashita, thank you so much for sharing the session.
No worries, no worries.
Our
My
distinguished
pleasure.
speaker, Professor Alan, it was mind-boggling actually. You showed the unstable design lab. I've never thought that there is such a lab called unstable design.
We should go there and visit.
Yeah, I think we should. Living metal lab. And those the tiles that lift. The Lego kind of bricks. That is amazing. And it seems like you really really enjoy working on this.
Yes.
And you have things like a listening lamp, the jam station. This is these are all interesting stuff. We should go there, Mashita. Yeah, one day.
Yes, one day.
And,
After
and we
COVID,
have,
after COVID.
and the audience as well. They
Yeah.
are very interested with your work, and perhaps they might want to go and see you in person. If they had the chance after COVID-19. Yeah.
Yes. Welcome. Everybody should come visit.
Thank you so much, Prof. Alan, for a very, very interesting talk there. Thank you, Mashita, for sharing the session. And to all our viewers, thank you for watching a UTM Engineering Distinguished Lecture Series. We have many more lectures for you. Do stay tuned. Until next time, bye-bye for now. Bye-bye.
Bye-bye.